Hi there, this is Mr. Schnitzius. I'm one of the A squared I geometry teachers, and this video is about lesson 6-2. We're going to complete two-column geometric proofs. So our learning targets for this activity are to complete two-column proofs to prove theorems about both segments and angles. So just to quickly review, these are going to be theorems because they're not simply based on recognizing patterns and saying, well, this looks like it's true for a while, I guess it's always true. We're going to use deductive reasoning to prove that these theorems are true. A proof uses deductive reasoning to change a conjecture into a theorem once it is proved. So since all of these are going to be geometric proofs, instead of solving an equation, we're going to prove something about geometric figures. And this is a review from activity 6-1. The reasons that we'll know that the statements that we're making are true are either going to be properties, definitions, postulates, or theorems. And so we're going to look at some examples and then step it up to where we're doing some fill-in-the-blank proofs. And then by the end of this activity, we'll be doing two-column proofs where we just do the whole proof ourselves. Before we dive into that, I wanted to show you a resource on the class website where you can find a handy list of all these properties and definitions and postulates or theorems. So on the class website, here is a list of places that we can go. Hopefully you've been navigating through these pretty successfully. If you're using the PDFs of the book to follow along or to do your homework, you can find those PDFs here. But then if you click on this textbook tab, Mr. Munyon uploaded an additional resource that's not on the ebook. So if you go to this supplementary material that's at the back of the Springboard book normally, if you scroll down to the 5th page, here's a list of all the properties that you're going to use in this class. Some of them we've talked about, some of them we haven't talked about already. But see, here's the transitive property. That was a big one in the last activity. There's the substitution property. There's the distributive property that we talked about. Here are all our properties of equality, where doing one thing, the same thing to both sides of an equation keeps the value of the equation the same. So this can be helpful as a resource to have all your properties in one place. Then if you scroll down to page 643, here's a list of all the postulates and theorems that we're going to use in this class. In this lesson, we're going to talk about the segment addition postulate that you learned about in activity 4. We're going to talk about the angle addition postulate. So this is we're not going to read through every single one of these theorems right now, but they're there on the book website or on the class website as a resource. Again, if you go to this textbook page, and there it is, geometry postulates and theorems. So we're going to dive in and we're going to look at some of the examples that your book gives you. This first example, if you're following along in the PDF, is on page 66. So this is the theorem that we're trying to prove. Vertical angles are always congruent. We could call that the vertical angles theorem. And so let's look at the given information. Every proof starts with a given statement, and then it has a statement that you're trying to prove. And we said in the last activity, a good starting point, if you don't have a picture, is draw out a picture and label it as you go along. Now, in this example, they didn't start with the given because the given was describing the picture. That is abnormal. You should always start your proof with the given statement. Okay? In fact, I'm going to do that up here to underscore that point, we're going to write that angle 1 and angle 2 are vertical angles. And we're going to say that the reason for that is that's a given. I'm not thrilled that they left that off in that example. So you always start with the given information. Now, if that is true, what else is true? Deductive reasoning is reasoning where, based on logic, we say, if we know this, what else can we know? If we know those two things, what else can we know? So we know that the measure of angle 1 plus the measure of angle 3 is 180 degrees. How do we know that? Well, we know that because of the definition of supplementary angles. From the picture, we can see that angle 1 and angle 3 make a line, therefore they are supplementary. Using that logic, we can also see that angle 2 and angle 3 have measures that add up to 180 degrees. That's also because of the definition of supplementary angles. So combining these two equations together would give us a new equation. The measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. And whenever we do problems like this in class, what I like to do is circle the measure of angle 2 plus the measure of angle 3 and draw an arrow to that 180 degrees. Because if it's true that the measure of angle 2 plus the measure of angle 3 equals 180 degrees, then anywhere that it says 180 degrees, we can substitute, we can plug in the measure of angle 2 plus the measure of angle 3. So that's one of the properties in the additional resource that I just showed you. That's the substitution property. So they didn't show the work here, but we could maybe show that work by putting minus the measure of angle 3 on this side of the equation and minus the measure of angle 3 on the right side of the equation. We subtracted the same quantity on both sides of the equation. Therefore, the value of the equation is still true. In algebra class, your algebra teacher might have showed you to cross those off when they cancel out. So we're left with the measure of angle 1 equals the measure of angle 2. And so if that is true, what do we know about congruent angles? If angles have the same measure, then they are congruent. So I'm going to mark that in the picture. Angle 1 and angle 2 are congruent. And something that happens a lot, students oftentimes get it in their mind, okay, I'm always supposed to start with the given information. I'm always supposed to end with the statement that I'm trying to prove. So that's easy to do because, hey, this is given. I put that first, and the reason is given. Okay, I'm supposed to end with the statement that I'm trying to prove. That's how we know that we're done. But if the reason at the beginning was given, well, maybe the reason at the end is supposed to be prove. The reason is never prove. Prove is not a reason. Remember, we said, what can our reasons be? They can be properties, definitions, postulates, or theorems. Prove is not one of those. Prove is a verb, right? So how do we know that we're done? Because we showed using deductive reasoning that if this initial information is true, if this given information is true, then I can follow this argument logically to see, oh, this is true, therefore, what I'm trying to prove, angle 1 is congruent to angle 2, that has to be true also. So let's look at another example. This one is a fill-in-the-blank proof, also on page 66. We're trying to prove that all right angles are congruent. If you were looking for a name for this theorem, it would be the right angle congruence theorem. Just like the name of the last theorem was the vertical angles theorem. So we're given that angle A and angle B are right angles. Okay, so that's always the given information. We're going to start with that. Something that I'm maybe not thrilled with is I don't have a picture. So we're going to draw out a picture. So this is a right angle, so I'm going to label that angle A. This is just a sketch. This is not perfect. That's okay. The purpose of drawing out your picture is to just keep track of what you know about the problem. So this is angle B, and that's also a right angle. Okay, so what do we know about right angles? Well, we know that when we put this right angle box right here, we know that that represents 90 degrees. So let's see, that's because of what definition? Well, it's the definition of a right angle. If an angle is a right angle, then it must be 90 degrees. All right, so if the measure of angle A equals 90 degrees and the measure of angle B equals 90 degrees, then the measure of angle A has to equal the measure of angle B. And that's true because of the transitive property. If the measure of angle A is equal to 90 degrees, if 90 degrees is equal to the measure of angle B, the only way for both of those statements to be true is if the measure of angle A equals the measure of angle B. So if these angles are the same measure, angles that have the same measure are congruent to each other. So that tells us that angle A is congruent to angle B. So how do we know that we're done? Well, we were trying to prove that angle A is congruent to angle B. That's the last statement in our proof. The only other thing that we need, though, is a reason. So what kind of angles are angle A and angle B? They are congruent angles. Two angles have the same measure, and by definition, they have to be congruent to each other. All right. So here's another fill-in-the-blank proof. This is on the next page in your PDF. This is on page 67. Given Q is the midpoint of segment PR. Also given segment QR is congruent to segment RS. Now this one's a little bit different because there are two different pieces of given information. So we always want to start a proof with the given information. That's easy. That should be easy points. So if Q is the midpoint of PR, what did we learn in an earlier activity about midpoints? A midpoint divides a segment into two congruent or equal pieces. So that means that we can mark that segment PQ and segment QR are congruent to each other. That's the symbol that shows that two segments are congruent to each other. So how do we know that? A lot of the times when you're looking for a reason, it's helpful to look back at the last statement. We were told that Q is the midpoint of segment PR. So it's because we know the properties of a midpoint, it's because we know what a midpoint is that allows us to conclude that these two smaller segments, PQ and QR, must be congruent to each other. So this is going to be because of the definition of midpoint. Now, you always have to put all of your given information into a proof. So we got two pieces of given information. First, we put Q as the midpoint of segment PR. They also told us when it says given, it's like somebody's walking up to you and saying, hey, I'm telling you that you know for sure that segment QR is congruent to segment RS. You don't have to worry about whether or not that is true. I'm telling you at the beginning of the problem that this is a true statement. So if that's a true statement, we can put it in the proof. That's given information. If there's more than one given statement, what sometimes will happen is people will put all the given information in one step, or we could have flip-flopped steps 2 and 3. So I'll put an arrow saying it's possible that you can switch those, and that will still be correct. What you can't do is you cannot flip-flop steps 3 and 4. Why is that? Well, a couple of reasons. The proof statement always needs to go last. What are we trying to prove? It's what we want to have go last. Plus, another thing to think, if all I know is that segment PQ is congruent to segment QR, that doesn't guarantee that segment PQ is the same length as segment RS. But if I look at the given information in step 3, segment QR is congruent to segment RS. And now I can just see from the picture that it's obvious that segment PQ and segment RS are congruent to each other. All three of these segments have one tick mark. They're all congruent to each other, but we need a reason that segment PQ is congruent to segment RS, and that's because of the transitive property. Segment PQ is congruent to segment QR is congruent to segment RS. The only way for both of those statements to be true is if segment PQ is congruent to segment RS. Here's another fill-in-the-blank proof. This time we're putting in the statements, and they've given the reasons to us. Okay, easy money. You always start with the given information. Angle 1 and angle 2 are supplementary. And then you might be saying, how do I know which one of those I was supposed to put there? Well, since we're talking about the definition of supplementary angles, that means that this first given statement should have something to do with supplementary angles, right? So what do we know about supplementary angles? If two angles are supplementary, then the sum of their measures equals 180 degrees. So then we can write out an equation, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay, so check. We did this first piece of given information. We still have another piece of given information that we can use. So that's the measure of angle 1 equals 68 degrees. So now we've used both pieces of given information. I guess I could label this angle as 68 degrees. But now we're going to do the substitution property. Remember what the substitution property says? It says if the measure of angle 1 equals 68 degrees, then anywhere I see the measure of angle 1, I can substitute, I can plug in 68 degrees. So we're going to substitute 68 degrees in for the measure of angle 1 in that step 2 equation, and we're going to get 68 degrees plus the measure of angle 2 equals 180 degrees. And then since the last reason is the subtraction property of equality, if we subtract 68 degrees on both sides of the equation, that's a valid thing to do. The golden rule of algebra says if you do one thing to one side, you have to do it to the other side too. Bam, those cancel out. And that leaves us with the measure of angle 2 equals 112 degrees. So how do we know that we did this correctly? Well, we're ending with the prove statement. And our reason is what allowed us to change the equation in step 4 into the prove statement in step 5. All right, so this question is pretty cool. There's a question similar to this in the homework in activity 6, which you can practice. It's not one of the required problems, but this is really similar to number 13 in the activity 6 practice. So they've given us statements and reasons that go together, and we need to put these in a logical order. So we're given that angle 1 and angle 2 are vertical angles, and we're also given that angle 1 is congruent to angle 3. Okay, so which of these pieces of given information should we put first? Let's go ahead and put that angle 1 and angle 2 are vertical angles. If that is true, let's see, what do we know about vertical angles? Actually, we proved this when we proved the vertical angles theorem. Vertical angles are congruent. So if that is true, then that means that angle 1 and angle 2 are congruent to each other. We can mark that in our picture. Now we've got kind of an easy decision to make. Which statement should go next? Should we put the next given piece of information, or should we put what we're trying to prove? What we're trying to prove always goes last. Always, always, always. So that means that this angle 1 is congruent to angle 3, given piece of information, has to go next. So marking that on our picture, it would look like this. Now we said so let's read through the proof to make sure that it makes sense. Angle 1 and angle 2 are vertical angles. How do we know that? They told us, and we know that that's true. If angle 1 and angle 2 are vertical angles, well, then they have to be congruent to each other. How do we know that? Because vertical angles are always congruent. Okay. Then they also told us that angle 1 is congruent to angle 3. That's given. Well, if angle 1 is congruent to angle 2, and angle 1 is also congruent to angle 3, angle 2 and angle 3 have to be congruent to each other. That's the transitive property. So logically, there's a good flow to this proof. And I showed you earlier that we could have switched 2 steps in this proof. Let's see what that looks like here. If we switch around the order of steps 2 and 3, let's see if this still makes sense. So we put both pieces of given information first. All right. So that would be marking these top 2 angles. If step 1 is true, then the vertical angles, angles 1 and 2, have to be congruent, so we would still end up with the same picture. And lastly, we could say that angle 2 is congruent to angle 3. So sometimes there's more than one right way to order your steps. Just be sure that if you have a piece of given information and you're using that piece of given information to draw another conclusion, make sure that the conclusion goes after the given information. One last thing that I wanted to show you on this problem, this vertical angles are congruent. We call that the vertical angles theorem. That's the name of the theorem that we proved as the very first example in this activity. Okay, so here's an example of a 2-column proof where we've got just the given information and what we're trying to prove, and they don't give us any information to start with. We've got to do the whole proof ourselves. Okay, so it says given angle R and angle S are each supplementary to angle T. Well, let's start off with the given information. Angle R and angle S are each supplementary to angle T. That's given. That's easy. Okay. If we know that, what do we know about supplementary angles? We know that supplementary angles are angles whose measures add to 180 degrees. So that means we can write out 2 different equations. The measure of angle R plus the measure of angle T equals 180 degrees. And also, the measure of angle S plus the measure of angle T equals 180 degrees. How do we know that we can do that? Because we know what supplementary angles are. Okay, so if that is true, then let's see, I think the next step is going to be some sort of equation. Let's look at what equation that is. The measure of angle R plus the measure of angle T equals the measure of angle S plus the measure of angle T. Yeah, both of these sums are equal to 180 degrees. If they're both equal to 180 degrees, that means that they must be equal to each other. So that is true because of the transitive property. So let's stop now and take a second to think about where we're going. We want to prove that the measure of angle that angle R is congruent to angle S. We've almost got that, but we've got this pesky measure of angle T on both sides of the equal sign in this equation. How could we get just the measure of angle R and just the measure of angle S? Well, if we can take away the measure of angle T on both sides of the equal sign, we'll be closer to where we're trying to go. And we're allowed to do that by using the subtraction property of equality. I really like showing the work in these proofs. So we're going to put minus the measure of angle T, minus the measure of angle T. Those are going to cancel each other out. So if these 2 angle measures are equal to each other, that means that the 2 angles, angle R and angle S, have to be congruent to each other. If 2 angles have the same measurement, then they must be congruent to each other. So we're going to look at two more examples, and these are on the lesson 6-2 practice. This is on page 70 of the PDF if you're following along. Given angle 1 is complementary to angle 2 and segment BE bisects angle DBC. So this one is kind of neat because it uses some postulates and definitions that we haven't seen already in this activity. So start with the given information. That's easy. That should be a real gimme by now. Okay, so how do we know if segment BE bisects angle DBC? How do we know that angle 2 and angle 3 are congruent? Well, what does it mean to bisect something? An angle bisector cuts an angle into two smaller congruent angles. So that's because we know what an angle bisector is. That's because of the definition of an angle bisector. Okay, they give us a clue here with this reason. The reason for step 3 is the definition of congruent angles. So we've been using the definition of congruent angles to say if two angles have the same measure, then they must be congruent. But this is just using the converse of that definition. If two angles are congruent, then their measures have to be equal. If angle 2 is congruent to angle 3, then the measure of angle 2 has to equal the measure of angle 3. Okay, so why do we put this first given information in first? We know that this is true. We figured out everything we can know based on this piece of given information. So we've kind of reached the end of the road for this piece of given information. So we want to try to figure out what we can prove based on angle 1 being complementary to angle 2. That's given. What are complementary angles? Complementary angles are angles whose measures sum to 90 degrees. So that's going to go in this blank right here. How do we know that? It's because we know what complementary angles are. Is that going to be a definition, a postulate, or a theorem? Well, just like we use the definition of angle bisector for reason 2, this is going to be the definition of complementary angles. So now let's look at what we have changed in step 5 to get to step 6. Can you see the only difference between step 5 and step 6? It's we changed the measure of angle 2 to the measure of angle 3. So we're plugging in the measure of angle 3 where the measure of angle 2 used to be. How do we know that? Because in step 3, the measure of angle 2 equals the measure of angle 3. So we can plug in, we can replace the measure of angle 2 with the measure of angle 3. So let's see. This is telling us that these two angle measures add up to 90 degrees. What do we know about angles whose measures add up to 90 degrees? We know that they're complementary. So that gives us the statement that we were trying to prove. Okay, one last proof here. This is number 7 on the lesson 6-2 practice. So this is another one where we have to do it all on our own. There's no blanks. They just give us the given information. They give us the statement we're trying to prove. We've got to go for it. All right, so this is one where we just list out all the given information at the beginning. So we're going to mark that. Segment PQ is congruent to segment QR. Segment QR has a length of 14. Segment PR has a length of 14. So before we unveil what the steps are, let's just get a roadmap for what we're trying to show. I want to know that segment PQ is congruent to segment PR. Well, what do we know about congruent segments? They have equal lengths, right? So I know that the length of segment PR is 14. If I could just show that the length of segment PQ is 14 as well, then I'd be in business. And that should be easy to do because they told us in the given information that we know is true that segment PQ is congruent to segment QR. So let's see how we can write that out step by step. Segment QR has the same length as segment PR. Both of these segments have lengths that are equal to 14, therefore they're equal to each other. Okay, if that is true, then segment QR is congruent to segment PR. If two segments have the same length, then they are congruent. So now we can mark that in our picture. That's why we like to draw out the picture. Okay, but now we can use the transitive property for the congruent segments. Segment PQ is congruent to segment QR. Segment QR is also congruent to segment PR. Therefore, segment PQ is congruent to segment PR. Okay, we can already see that based on the picture, but now we have that stated as a statement in our proof, and the reason is because of the transitive property. So feel free to use these examples to help you on the 4 problems in your Activity 6 homework. Remember, if you go step by step, if you start with the given information and end with the statement that you're trying to prove, and you just go a little bit at a time and say, if I know this is true, what else can I know? Then after a little bit of practice, these 2-column proofs will start to be really a lot simpler. Thank you guys so much for your hard work. Have a good one.